Okay, we're going to take a look at example 4. Jay is moving from Miami to Orlando. He is looking to hire Move Out to help him move, and they have two options. Find the cost per hour for loading, unloading, and packing, unpacking. So we've got a weekday move and a weekend move with two different costs. You can see here that they will do 6 hours of loading and unloading and 5 hours of packing and unpacking for a total of $720. Weekend move, 4 hours of loading and unloading, 2 hours of packing and unpacking for a $400 total cost. You guys, when you move, if you pay someone to help you move, they're going to give you an hourly rate. It probably won't be set up like this, but what we are going to do on these ones to solve them is actually set up a system of equations. And that's where you have the two equations that you solve by look to see where they intersect. I know that that's a lot more challenging than it could be, but this is the easiest way to solve it. And rather than make you solve it by combination or substitution, you're going to get to solve it by plugging it into Desmos. So it's actually going to make life pretty easy. So I'm going to look at my weekday option, the weekday option first. So weekday option says 6 hours of loading and unloading. You guys, I'm going to call this whatever the first. There we go. I'm trying to make that an X. I'm gonna whatever that first thing that's listed, in this case, loading and unloading, I'm gonna call that X. 5 hours of packing and unpacking, I'm gonna call that my Y, and I'm gonna set up a real easy equation to solve. So 6 hours of loading and unloading looks like 6X. Nothing crazy about that. Plus, they are also gonna do 5 hours of packing and unpacking, so we will call that Y. And the total there is going to be $720. Nothing crazy about setting this up. And then Desmos is going to do all the hard work for us. Then we're going to do the weekend move over here. So the weekend move, you get way less time. They do 4 hours of loading and unloading. And again, that's going to be my X and this is going to be my Y. So 4X plus 2 hours of packing and unpacking becomes 2Y. And the total cost is going to be $400. So rather than go through the pain of solving by elimination, I am going to go to handy dandy Desmos, and I'm going to type that in. 6X plus 4Y, 5Y. See, good thing I checked. 5Y equals 720. I can't see it on the screen yet, but that's okay. We're going to fix that in a minute. 4X plus 2Y equals 400. 4X plus 2Y equals 400. And so we can't really see these because they went off the screen. And in order to see them better, I'm going to have you guys just zoom out until you see the lines. See, I can kind of see them. And if you don't see that nice gray point that I see right there, you can always click an intercept. Usually helps those start to show up a little bit. So what this looks like is that we got an intersection point of 70, 60. Hang on, I'm gonna solve that right here. I'm gonna write that down. So we've got an intersection point of 70, 60. We know that when we are dealing with a graph and we get a point like that, that our first value is always X and our second value is always Y. So what we know is that for loading and unloading, they were gonna charge you $70 an hour. And that for packing and unpacking, which is the Y value, they are charging you $60 an hour. You guys, when we do your assignment today, you're going to get the same question twice. You're going to give me just the X value, just the number. Like if this was the example or if this was your assignment question, on the first one, you're only going to tell me the X value of 70. On the second question for the Y value, you would only give me the 60. So don't give me the point. Just tell me one of them at a time. Okay? But what we are looking for is that intersection point to find both of those.